Hi, this is Mr. Springer with your e-learning assignment for Saturday, February 2nd, 2019. What we'll be considering today is the reaction between a strong acid, in this case we'll use hydrochloric acid as our example, with a strong base. We'll use sodium hydroxide as our base. We're going to look at how the pH changes as small amounts of the base is added to a sample of the acid. So let's imagine that we've got a 10 milliliter sample of 0.1 molar HCl in a beaker. The pH of that acid is the negative log of the hydrogen ion concentration, which in this case, being a strong acid, the hydrogen ion concentration is the same as the acid concentration because it completely dissociates. So the pH will be the negative log of 0.100, which will be 1.00. The first line on my table here represents that situation. The moles of HCl are calculated by multiplying the molarity times the volume. Molarity times the volume. Molarity is 0.1 moles per liter, 10 milliliters, and we know there's 1,000 milliliters per liter. Got to make that adjustment to cancel out the milliliters, which gives us 0.00100 moles of HCl right here. We have added exactly 0 sodium hydroxide, so the moles of H plus are the same as the moles of the HCl. The total volume is 10 milliliters, so the H plus concentration is 0.100, pH of 1.00. Now you might be wondering, well, where does this number come from, the 1 times 10 to the minus 13? I didn't think there was any hydroxide in the beaker. Well, you need to remember from earlier that water self-ionizes according to this equation where the equilibrium constant for water, hydrogen ion concentration times hydroxide ion concentration, 1 times 10 to the minus 14th. So the hydroxide ion concentration will be 1 times 10 to the minus 14th divided by the hydrogen ion concentration, which we just said was 0.1, or 1 times 10 to the minus 1. So 10 to the minus 14th divided by 10 to the minus 1, 1 times 10 to the minus 13th moles per liter hydroxide ion, which we've included right there. It's not really important at this point in the process, but that's how it's calculated. Okay, and you can see here that when we do the next one, after we've added 1 milliliter, the hydrogen ion concentration is going to be 0.082. So if we divide our 10 to the minus 14th by 0.082, we'll get 1.22 times 10 to the minus 13th, which we enter right there. Again, not too crucial at this point. So as we start adding the sodium hydroxide, we'll be adding either 1 or 2 or 0.1 milliliter aliquots. And just so we know how much we're actually adding, since it's a 10th molar solution, just like the hydrochloric acid was, a milliliter of that would be 0.0010 liters, so 0.1 moles per liter times 0.001 liters, liters cancel, 0.0010 moles of sodium hydroxide. For each 10th molar, we're adding 0.0010 moles of hydroxide ion, or sodium hydroxide. Alright, so as we can see, since the entire 10 milliliters was added all at once, this whole column on my chart is 10 and my moles is 0.001. Because we're not adding anymore, we're not taking any away, it's always there. Okay, we're adding a different amount of sodium hydroxide. So I went ahead and determined how much sodium hydroxide I wanted to add for each aliquot. Took care of that. So remember, 1 milliliter was 0.0001 moles. So if we have 3 milliliters, 0.003, 5, 0.0005, and so on down the chart. When we get to the 0.1s, 0.0091, 92, 93. See how this is working? I hope you do. Alright, so at this point, it's all stoichiometry from here. In the second row, we had 1 milliliter, which was 0.00100 moles. In order to determine, since it's stoichiometry, it's a 1-to-1 ratio, so every bit of this gets used up, and it uses up exactly that much of the acid. So we went from 0.001 to 0.009 because we've removed 0.0001 milliliter of the acid. And here we go. 0.001 mole of acid minus 0.001 mole of the sodium hydroxide leaves me that much, many moles of hydrogen ion remaining. Right there. There's no hydroxide ion remaining. It all got used up. Okay. So, how do I get the hydrogen ion concentration from there? I'll take my number of moles of hydrogen ion, 0.009, divided by the volume in liters, 11 milliliters is 0.0110 liters. I get a concentration of 0.082, which I enter right here. And I take the negative log of that to get my pH, 1.09, enter that right there. For the next row, I'm adding a total of 3 milliliters, the one there plus 2 more, which amounts to 0.0003 moles of NaOH. So we're going to subtract the 0.0003 from the 0.001. I get 0.0070 moles of H plus remaining, right there. All the OH is used. Volume added is 13, so the 0.0007 divided by 0.013 is 0.054, which I put right here. And I do the negative log of the 0.054, I get 1.28. There it is, pH. Notice pH is going up each time. As we add base, the pH gets higher, becomes less acidic as we add base. The next 3 lines on the table, we add 5, 7, 9 milliliters, which increases the NaOH from 0.005, 0.007, 0.009, reducing the H plus each time by the same amount. There's my total volumes. There's my hydrogen ion concentrations. And there are my pHs. So notice that when we went from 0 sodium hydroxide added to 9 milliliters of sodium hydroxide added, the pH only changed from 1 to 2.28, which is a difference of 1.28 pH units. Not a very big change. We've added almost the same amount of base as we have acid, but we've only changed the pH by a little over 1 pH unit. Okay. Now imagine, since this is stoichiometry, when we add that 10th milliliter, this number here, 0.001, and this number here will also be 0.001. So there'll be no hydrogen ion left, no hydroxide ion left at the 10 milliliter mark. Let's go ahead down there. At the 10 milliliter mark, these are equal. So there's no hydrogen ion left, no hydroxide ion left. 20 milliliters is the total amount added, but notice the pH is 7. Why is it 7? Well, the acid and the base have neutralized one another, leaving only water. And according to our ionization of water, autoionization of water, we should get a hydrogen ion concentration of neutral water to be 1 times 10 to the minus 7, which gives us a pH of 7. So both of these are filled in as 10 to the minus 7. Get a pH of 7. Okay. So we went in 10th milliliter aliquots from here. 9.1, 2, 3, 4, 5, 6, 7. Changing these now 0.091, 0.092. So we're getting a smaller amount of H plus left. Still have no hydroxide ion left over. We're still more acid than base at this point. The volume keeps going up. Here's my hydrogen ion concentrations. As we're going up to 9.9, from 9.0 to 9.9. And my pH goes up a little bit more profoundly. Well, it doesn't look like a whole lot, but remember we're only adding 1/10 of a milliliter at a time rather than a whole milliliter at a time. So by the time we get from 9.9, where it's 3.3, to 10.0, huge jump in pH. Okay. So there's the situation where it has a neutralized pH of 7. Now we're going to keep adding 10th milliliters at a time of the sodium hydroxide. See, 1.1, 10.1 all the way up to 10.9. This keeps going up by the same amount. See, it's 99, 100, 101, 102, 103, 104, 105. See, these numbers look a whole lot like those numbers. But now, since we've used up all the acid, there's no longer any acid left over. So this hydroxide ion now will be what we'll have to use to calculate the pH. We can take this number, the 0.0001 moles divided by 0.0201 liters to get 0.00050 moles per liter. That's the hydroxide. Once we've done that, we can use that number to calculate the H plus concentration, 2 times 10 to the minus 11, 2 times 10 to the minus 11, and then negative log that, we'll get 10.70. Okay. And it goes similarly from there. So we went from 3.3 at 9.9 to 7 at 10.0 to 10.7 at 10.2. Keeps going up from there according to the same pattern all the way up through 11.0 where it's 11.68. Then from there I've started adding 1 milliliter at a time until I got bored with this at 15 milliliters total added, where the pH is 12.30. Okay, so what I'd like you to do, there's an Excel document you can use. Graph milliliters of NaOH added versus pH. When you put, all you'll have to do is enter the pH into the spreadsheet, and it will draw you the graph of the strong acid, strong base titration curve. Once you've got that, I'd like you to email that to me. If you are not in my class and you'd still like to do this, it's real easy. You just make a graph or make a chart on Excel. First column is the NaOH added. The second column is pH, and make it to draw you and have it insert an XY scatter chart with the smooth line connecting the dots, and you'll make yourself a nice graph. I set mine to where it would always give me 2 decimal places on both columns. So you can see there's the up through 9.5. You can pause this if you need to get those numbers for your graph. Then we'll go up here from 9.5, you can see, to 10.5 on that screen. Pause again if necessary. And the rest of it is right there. So, I thank you, and send me those graphs.